This is a very detailed tutorial on the use of operation-driven transitions in state machines and the use of activities as entry and exit behaviors of states. We're going to see how we can simulate a telephone dialer as depicted in a Unified Modeling Language version 2.5.1, figure 14.7, Composite State with two states. Please note this is a presentation by WebL IT, not from the tool developers. This presentation contains some examples of the use of the action language for Foundational UML, Alf. This requires an additional commercial Alf plugin for MagicDraw or Cameo. You can, however, achieve similar results using the vendor-specific action language helper, which we illustrate in an appendix. There's also a detailed slide version of this tutorial online at this link. We're going to look at modeling a state machine based on a diagram in UML 2.5.1 specification, figure 14.7, Composite State with two states. It describes a composite state dialing with start and partial dial states. It turns out to be easier to do this using the composite state embedded in another state machine, just as an implementation convenience. However, to model this, we have to build a bit of an ecosystem around it. We're going to look in particular at how activities used as entry behaviors and exit behaviors of states help bring state machines to life. Now, before we look at the entire mini-system in detail, I'm going to execute the system, simulate it in Cameo Systems Modeler. If you have MagicDraw, by the way, you can just get the Cameo Simulation Toolkit plugin. Cameo Systems Modeler has the Simulation Toolkit bundled with it, so they are the same thing. Now, the first time I do this simulation, I'm going to do it quite quickly. You can actually set the animation speed. Then at the end of this presentation, we'll go through it very slowly once you've seen all of the different diagrams. This is just to give you a feel for where we're heading, to see what the system's intended to do. So we can launch from here, simulation, run. I'm running from the class, so I'm running from the top level context. Before I go start, I set the animation speed about there, will do for the moment. And you'll notice that it's already brought up the activity that was set as the classifier behavior for the top level controller block. Okay, so let's run. It enters the state machine for the dialer of the controller. Because it's entering it, it's hit the start dial tone entry behavior, and now we are inside the behavior of the controller. It has started a sub-activity, catch dial N, which has these different accept event actions corresponding to the signals for our phone. We have here different signals. Note that it is offering connect. We'll look at that later. But we're actually going to get a connection to happen automatically first shot by putting in 4 only digits. We're using a mini phone number. Okay, so I'll dial the number 2. It accepts it. It sends it to dial N. Dial N reads itself, comes into the dialer. Dialer calls digit digit causes, in fact, a transition in the state machine, and now it adds a number, appends it to the list of digits controlled by the number class. As part of the append activity, that is the method of the append operation, it adds a digit as a structural feature addition, and now we are back through the cycle, ready to catch another digit. So let's just go through that a few times. See if we can see again what's happening. I'll send a 3. Comes into dial N. It reads the context, which is the controller, from which it then obtains the dialer. It calls the digit operation on the dialer. It then prints the number, the digit, and we can see here there's the digit that came in, there's the number we added before. We're now going to append a new digit. Calls append on number, which has an activity as method. It prints the digit. There's our digit 3 printed here in the window. Adds the structural feature value to our list of numbers. It's appended it, and now we are ready to go again. So it has to reset those accept event actions. All right, I'll speed it up, just move through now. You can look at it in detail at the end. I'll do a 2 again, just to prove that you can use numbers of the same. Just letting it run through this time without further remarks, so we can see we're ready to go. We now have 3 numbers accumulated, and if I do a 4th number, which I'll make a 0, now in the state machine it will take a guarded transition when it performs this append. Here we go. So it's set, ready to go. On exit, it prints the number. It is now connecting. It has performed that final transition. It's connecting. Number is valid, so connecting. And that's the end of our sequence. Now, don't be concerned if you didn't see all of that. We're going to go through it very slowly at the end. But so that you understand it better, we're going to look first at each of those parts of the system. We're going to look at the activity aspect, and we're going to look at the state machine aspect and see how they work together. This overview diagram is a little more complex than I would usually recommend. However, it shows our entire mini system in one place. We have some signals that represent the buttons on a telephone. We have 1 button per signal. It's a little tedious, but it seems that that's the only way we can do it in Cameo Simulation Toolkit, because the simulator does not permit the entry by users of attribute values during the execution, but it works well enough. Decided not to use the Cameo user interface button system. Where possible, we want to just use straight UML. Let's start at the top of the system. We have a controller that has a dialer. The dialer carries our state machine of interest inside here. The dialer has a number class. The number class carries an ordered list of non-unique integer numbers. I'm using the small int int from MagicDraw. That's not official UML, just for convenience because it's concise. It's a data type available in a supplementary library from MagicDraw. We have a number of activities. We'll be looking at each of these in turn. Let's look at each part of this carefully before we perform the simulation execution. Let's start with our number signals. Each signal corresponds to a button you might have on a telephone. They have the numbers 1, 2, 3, 4, etc. 9, 0. Now, if you know your object orientation, of course, it would be nice to have them, in fact, extend an abstract base signal n and redefine this attribute. However, it turns out that if you do that with an unmarshaled accept event action in Cameo, it causes chaos. So, for the moment, we have tedious buttons N1 to N9 and N0, but it works fine. Okay, I'm going to start right down the bottom of the system at number class. We have here an ordered, non-unique list of ints, where int is in fact a data type from MagicDraw, not part of standard UML, but it's convenient because it's concise. It has some operations. It's valid to determine whether the number is valid. For this, we're going to be using a very simple test. We're going to test that the number has 4 digits in it, which of course is not realistic, but we want to be able to do our simulation quickly. This opaque behavior is valid, is the method of this operation. And we see that I'm using the language Bean Shell scripting language as the action language choice for most, but not all, of the opaque expressions. There's our simple test there, n size equals to 4. It has an operation for appending a digit, n, to our list of digits here. That activity there is more involved. We'll look at that shortly. There's a simple operation here that has an opaque behavior assigned as method that prints the number to the terminal window in the simulator. It will print the entire list of numbers. Now, these are also listed in the owned behaviors compartment. We see that the append activity has a parameter n for the digits, and the is valid, opaque, and print number opaque behaviors are also listed there. Okay, let's have a look at the append activity. The first thing to note is that it has an activity parameter node that corresponds with the input parameter. There's a fork here so that we can print the digit using a simple opaque expression, opaque behavior via a call behavior action here. All it does is print the digit to the terminal window. And the value is also sent to this add structural feature value action. Comes in through here prints, and then it reads itself a context for the activity, which will be of type number. That's then given as the object that carries the structural feature n, our list of digits, to which we wish to add this value. And it's very important that we set is replace all false because we wish to accumulate the digits. It turns out it's absolutely critical if you're using an add structural feature value action that you know whether you're using an ordered attribute and whether it's unique, because that determines whether or not you need the insert at pin, input pin, to control the assertion point and how this action behaves. So I've gone for using the unlimited indicator, which is an unlimited natural number, to drive this pin. It's a bit tricky doing this in the tool. You have to make sure, if you do this, that the value here is in fact defined as a literal unlimited natural. I'll just show you that working. If you click on that, and in fact, we'll default set it to 0, then you can set it to star, asterisk, and then it will work. Okay, so that drives the insert at pin, and if we read here, it means that it will insert the new value at the end of the sequence, which is what we want. Okay, so that helps us accumulate our value. Right. Let's now look at the dialer. The dialer has a digit operation which is going to be used on the transitions of the state machine. You'll note that it does not have a method assigned. We'll see why shortly. It has a simple opaque behavior for printing the digit, which again uses bean shell. And there's our state machine. Now the state machine has this funny looking own behavior here. That is generated by the action language for Foundational UML, Alf, on one transition guard, for which I found Alf convenient. Now I'd set myself the goal to do this entire thing without using Alf, and you can do it using the action language helper for Cameo, but it's not quite as elegant. At the end, we'll look at how you can achieve the same without using Alf. We also have these activities here. This is going to be entry behavior for start state in a state machine. This will be an exit behavior. And these are entry and exit behaviors of the state partial dial. We're going to look at these in some detail because they are critical to the system. There's an additional activity here, which is going to be an effect activity on the transition that leaves the partial dial state, as we'll see in the state machine. So before looking at those, I'll just show how they relate to the state machine so we can see where we're going with them. The state machine, it's basically just a wrapper for the part illustrated in this figure in the spec. When we enter the composite state, we come in here, and when we enter start, there's an entry behavior, which is this activity start dial tone. When we leave it, it'll execute stop dial tone. All they do is just print a message. They're very simple. There's our digit operation. So that's the trigger for the transition. A trigger of event type call event for the operation digit. And the notation here corresponds quite well to the spec figure notation. So when that operation is called, noting it does not have a method on it, this transition will be triggered and will reach the partial dial state, where it will then execute the entry behavior number.append. Now, this name here is a little unusual, and I've basically hacked the name by using that as the activity name to try to mimic what's done in the spec. It's not clear at all how the notation in the spec should be interpreted in this case. And the same for here, this exit behavior number.print. There's an activity with that name. So whenever this transition takes place here, or in the end, if the number is valid, this transition here, that exit activity will be performed, so it will print the current accumulated list of digits. This one is called a self transition or transition to self. And this I'll be calling the final transition. Goes from here to the final state, but only when this number is valid. Now, we're going to look at this closer later, but that uses Alf again for convenient access to this operation of number. And here's our additional effect. This is not in the spec diagram. I've just put that in there for convenience, so we can easily see when the transition is taken. And it will then also send a connect signal back to the top level to indicate that it's time to connect. And then we have this activity when valid. That is the final transition in our state machine executed as an effect on the transition when the number is valid. So what it does here is print a simple message, again using Bean shell. It reads itself, where the context is now a dialer, and uses this as the object from which it can obtain a controller, because it has a reference upstream to its parent controller, which we can then use as the target for a send signal action and send a signal event with signal type connect. And that will be received at our top level controller behavior. Right, so that's those activities there involved with the state machine of dialer. We need to control the entire lot coordinated using this top level controller. It has a top level activity that uses an activity which catches our dialed numbers and then dials them using this activity, adds them to the list of digits, ultimately to the number of a dialer. And there's an activity connect for us to use at the end. So these are owned behaviors, and controller is the classify behavior. Before looking at the top level activity, I'm actually going to look at these lower level ones so we can see how they are used. And then we're going to see how the entire collection of activities are coordinated. Okay, a dial N takes in a digit and ultimately uses it to call the digit operation. So we'll use a call operation action. And in order to use that call operation action, it has to obtain a reference to the dialer. Now the context of this is the controller. So when it does read self, a read self action, the result will be a controller object on which we can then use a read structural feature action to read the dialer feature, which is of type dialer, and then we can execute the call operation action on that dialer to pass in this digit. Let's look at one level higher up. Catch dial N has accept event actions with event type signal event. This one has a trigger for the signal N0 and so forth for each of the buttons or dials on the telephone. You'll note that it has is unmarshal set. That means that this attribute N, representing the digit, can be extracted from each of those accept event actions and then used to drive our dial N activity. We have a call behavior action with a behavior dial N. Now we want to use that in turn at a higher level in our controller. So there's our catch dial N. Now note that it's in a loop of sorts here. This goes round in circles, restarting those accept event actions until a button is dialed. There's no explicit end to it. That's because we're going to force it to end using, instead, the connect signal. Just one little warning here. There's a subtlety, an idiosyncrasy of Cameo Simulation Toolkit. It turns out to be quite difficult to coordinate different groups or loops of accept event actions. So to do that, this additional fork was required here. So we essentially have it forking to this loop here that has accept event actions inside it, and this one. So let's look at what's going on here. Remember that when our final transition comes from that state machine, it will send a connect signal. When the connect signal is received, it passes to a decision node. And we have a guard in the Alf language and the special guard else, which will be taken if this does not evaluate as true. So if it is true that the number of the dialer is valid, we'll then go to the connect action, which simply prints connect through an opaque action, reads itself to get the context controller from which the dialer is obtained using a read structural feature action, and then another read structural feature action gives us the number, and we then use the print operation of the number to print the number. However, if the number is not yet valid, we go this part. We print that the number can't dial yet. Go back through a merge node to reactivate the accept event action. So why might this be invalid? After all, we only sent that signal after we checked the guard to make sure it is valid. Well, the reason it's there is we can also, through the Cameo Simulation Toolkit window, send that connect signal directly at any time. So if we send the connect signal prematurely, it will in fact fail. Go back through here. So what we'll do when we run the simulation is we'll go through with a valid number first, and then we'll show what happens if you try to connect prematurely. Okay, now we know all the pieces of the system. We're going to run the simulation very slowly at first. Now remember, as you do this, you can change the animation speed, and you can also pause the animation as you go along. There's another setting worth knowing about. If you go to Options, Environment, Simulation, you may wish to check your model before execution. I have that off, but this is a good trick here. Auto open diagrams. Your mileage with it varies. Sometimes it's not what you want. Sometimes you want to, for example, just look at the state machine and just see transitions within a state machine diagram. But we're going to do it. And another trick here that sometimes works for you is you can use split pane here using the, I can't see it here now because I've split it. You can choose to make horizontal and vertical tabs when you have more than one diagram there. That's another thing to remember, is that you can in fact move back through the diagrams you've already visited using the arrow on the diagrams as and when available. All right, let's give it a go. We're going to start painfully slowly for the first numbers, and then we're going to increase the speed. So I'm going to really go down low there. Okay, our class controller is initialized, and we run. So it's entered first the state machine of the dialer. I'll just pause there, make it clear what's happened. The controller has a dialer. It has one dialer. It must create one. And when it creates the dialer, because it's the classifier behavior of the dialer, it has started the state machine. It's going to come in here and into start. When it comes into start, because that state has an entry behavior, start dial tone, it will then invoke this activity. So let's see that happen first. So in it comes into the start state, and there is our entry behavior. And prints to screen. That completes. Now, pause again. We're now into the activity of the controller. So the behavior of the child parts has started before its own classifier behavior. I'll just use this to go back to the state machine of the dialer being a child part of it. Okay, so now it's going to come into this fork. I mentioned that having that fork is basically a little trick that you need in Cameo Simulation Toolkit to get this to work, because it has trouble when there are multiple cycles with accept event actions. This is a workaround for that. So we're going to come into here and into here. It does not say in the UML spec in which order this must happen. All that matters is that it ultimately synchronizes properly, which it will. Okay, so let's move through here now, and it has gone into those merge points and into our catch. So we'll now just run through, activate each of those accept event actions. Note that it does not have an explicit initial node and start for those. They don't need it. They will start without it. If you do have a control flow into them, that changes that behavior. So without a control flow, they will automatically activate. So they're going to sit there and wait now for a signal. Now, remember that our main focus is on when this digit operation is going to be invoked. It will be invoked as part of the sequence of calling this guy here. So it's waiting now for signal. We're not going to use the connect signal explicitly yet. We'll look at that again after. Let's start with a 6. Let's do this nice and slowly. So in comes the 6. It has unmarshaled the value n, and it has passed it through a call behavior action to a usage of dial n. The context for it is controller. So it reads itself, gets the controller object, and then uses a read structural feature action to get at the dialer. The dialer is used as a target for a call operation action. It now calls digit. Now I'm just going to pause there. I said we're looking out for the invocation of that. It does not have a method assigned to it. Deliberately. Okay, so let's proceed and watch for this transition here. Firstly, it's calling stop dial tone because it is in fact hitting this transition, but it knows it's exiting, so it has to run this exit first. So that completes, and now the transition takes place. I'll just go back here so we can see where we are on our top level controller. So from the point of view of the top level controller, we are inside there. From the point of view of the dialer, we're inside this state machine, and it has taken that transition there. Now, because it's got a partial dial state here with an entry behavior, it's going to execute this strangely hacked named number.append as soon as this enters. So let's watch that happen. It now goes into number.append. The context is going to be the dialer, which it reads using the read self action. It reads the number using the read structural feature action. The number object has an append operation. Now, that is a call operation action. In fact, the method of that is an activity called append. So this then is going to call its method. This operation does have a method assigned, and so it will be caught by that. So we are now in the append. So just pause. We fork the object flow to these two input pins. It will synchronize back through this. All that does at the top is then print the digit using an opaque behavior. It then reads itself being a number. And here's our trick with the literal unlimited natural value asterisk, which means that the add structural feature value action will add the value, insert the value at the end of the sequence. And so we now have completed that append, and from the point of view of the controller, we've now exited one catch and dial sequence. It resets the catch and dial sequence, ready to receive the next number. Now, while that's resetting all of these guys here, let's have a look over here. We're now in that state. It is not always so clear from the colors in the animation. But what that stands for is the last called part. We're actually in here. It has executed this guy. So now, if we cause digit, the operation, to be invoked, it will now be able to perform this transition. And when it does, it will exit first here and perform the number.print activity. So let's watch that happen. I will send, last time I sent a 6, so I'll send a 4. I'm going to keep it slow just until we've gone through each of those phases. All right, so it's doing the dial in again. It reads the controller, gets the controller, gets a dialer from the controller. Once it's got the dialer, it can call digit. And just to do this slowly, because we've lost the state machine, what I'll do is, this is the trick. I'll make sure that our state machine is visible. Obviously, if it's going through quickly, you can't do this. If you're going slowly, you can do it. Otherwise, it's hard to see what's going on. So, when it hits this digit, it's going to cause this transition. Let's see that happen. It hits digit. Digit has no method on it. And there it is. We know it's hit it because it's performed the exit. So the exit prints the current number to the terminal window. All that is a call operation action with a method that is in fact an opaque behavior that prints the accumulated numbers so far. So we had a 6. Remember, we haven't actually added the digit yet. So it has to append it. So that's what it does now. It goes into number.append. It has now come back into the state. It will now call append on the number, which will go through that sequence with the append activity. It will do its little fork here so that it can print the digit that was sent in. We'll see the digit appear down here in the terminal window. It will now print our digit 4. It then reads its context, read self action, gets a number. And the add structural feature value action will insert at the end of the sequence our digit, and we exit here and we're out of the controller side. So remember, that was from the controller side point of view. It was calling digit. From the dialer's point of view, it was performing exit and entry behaviors from the state. So there we can see how the two worlds speak to each other. In order to understand state machines as they are used in UML and SysML, we need to understand both the activity side and the state machine side. Okay, so we've gone through the cycle once more. I'll go through this time. We've got two numbers in. We're going to do 4. I'll do this one quickly. Just to move through because there's nothing new to learn there. It's gone through and we go through, dial, get our dialer, call digit, cause the number to print as it exits our transition. I'll see if I can get the state machine back up here. So I'm going too fast now. Doesn't matter, let it go through. Because on the last one, we'll do it very slowly and have a look. So it adds one more digit in. And we're back through the cycle and reset. Okay, so I'll see if I can get the state machine up again. There. Okay, so we've now got 3 accumulated numbers. Remember, this test says the number is valid when there's 4 digits, just as a convenience. All right, so when we do the 4th number, this transition will take place here. It will print our numbers so far, which are 3 digits. It will then, on entry, do one more append, but after that, this transition can fire. And when it does, the transition effect, when valid, activity will be executed before it moves to the end of this composite states sequence flow. All right, let's do it. Let's put the animation down very slow so you can see exactly what's happening. I will do the same number. Why am I doing the same number? I'm doing another 6 because it helps you test that add structural feature action, whether or not you have the settings right, because it matters whether it is ordered or and unique or non-unique. We want them non-unique because you can repeat numbers in a telephone number. Okay, so I will do the 6. It will fire here. Call our dial N. The dial N reads the controller object as context, uses a read structural feature action to obtain the dialer child part, on which it then executes using the call operation action one last time, we hope, the digit operation. Because there is an exit action that it should print the number as it performs the transition, it then does the number dot print. So we will then see that we have accumulated so far 3 digits. We haven't added the 4th digit in yet. Now, watch carefully, I'll just pause. I've done that number dot print. We have an entry number dot append to go. So in comes number dot append. Gets the context dialer, which is the object for the read structural feature action. Gets the number of the dialer. It then calls the append operation on the number, which then uses its method and append activity to, for one final time, print the digit. There's a digit 6. It will use the asterisk trick to stand for inserting it at the end of our list of little ints. And now it adds it in, and we've done our append, but let's just do it slowly now. Very slowly. I'll make sure I've got this ready to catch it so I can see. Just give me a second, I'll go back here. Okay, we have now done that. So we're on that state. The digit has caused that transition, the digit operation. It's about to come out. When it comes out, switch back here to close that off. I don't want to miss my, excuse me while I do this again. Bear with me, it is worth doing. I don't want to miss the transition. It comes out, let's see if I can do it like this. Go through catch dial in, it resets all that first. Right, while it's doing that, I'll see if I can bring him up here. I want the state machine. Lest we miss the state machine. There it is. All right, so it's resetting all of those, but they will not be used because now the sequencing of this is not determined by the UML spec. All that's required is it's consistent. The ordering can be a little bit tricky. So I've got all of those reset. I'm waiting for this transition here because the number now being 4 digits long is valid. And we'll see that happen when it, for one last time, prints the accumulated numbers. Let's see if we can catch it. All right. Okay. It has caught it. It's not so obvious it's caught it, but what it has done, if I just go back there, it's taking this transition now. The reason I know is it's performing that exit. It won't actually show it here until it's done the exit. So it will now print that number for one last time, reads the context, reads self-action, gives it a dialer. From the dialer, we get a number using a read structural feature action. There's our result, and it then prints the number. So very slowly now. There it is. It will pass the validation test. Okay, it is definitely on that transition because it's now performing the when valid effect. It is here. So we'll let it do its when valid. Number is valid, so connecting. It prints that to our simulation window here, the console. Reads context, which is a dialer, and very slowly now, it is obtained here using a read structural feature action, a reference to its parent controller. If you look at that initial class diagram, you'll see that the dialer in fact has an upstream reference to its owning parent. So it can then send a signal to the parent. Now, let's get the top level activity diagram done up. We've gone through here now. Remember, this is active and it's waiting for a signal. When this connect hits, this accept event action will catch it. See if we can see that in the diagram. So there it goes, send. I've caught it. Just pause there. You see how it caught here? Goes here to this decision node, and now it will do this check. It's either going to go this way or this way. But because we have in fact only performed that transition when the number is valid, it must pass. So we just see that it has finished its job here. Noting again, the sequencing is not determined by the spec. And if I go back, let's see if I can get this so we can see this guy happening. From the point of view of the controller, we're on this merge. So it will take some time to evaluate. If you have Alf running, I'll just pause for a second to show you something. If you have Alf running and the animation speed down, it can be strangely slow performing these types of guards. The way to fix that is to crank the animation speed right up so this is on the edge of there. So it is now thinking, is the number valid, which it gets via the dialer of the controller. The this variable gives it access to the controller, and then it can navigate to the dialer, to the number, to its operation. But trust me, it is doing it. It's just because the animation speed is down that it's taking a long time. Here we go. It has said it's okay. So it goes into the connect. Here it is. Prints connect. Reads the controller, reads the dialer, reads the number, then uses the print method. The only reason this is done here is to reuse this print. The principle is that the number class knows what the accumulated number is, so we should ask the number class to do the printing for us, which it does. All right, so that's the end of the entire sequence. Okay, so we've gone through once just by dialing numbers, and we've relied on the number validation to kick in to send a connect signal. But just to protect ourselves in the simulation, recall that the Cameo Simulation Toolkit interface offers that signal at any time. So in principle, you could invoke it at the wrong time. So we need to protect ourselves against that. And that's done over here using this logic. Remember our trick with the fork. Needed in Cameo Simulation Toolkit when you have multiple loops involving accept event actions. Recalling that there are accept event actions buried inside this guy. So let's look at the activation sequence. Initial node goes into a fork, activates the two different loops here, and we have a merge before the connect so that we can go straight back through there if the connect fails. Now, if I run this just putting one or two numbers in, or no numbers, and then try to connect, it won't pass this validation because the validation requires full numbers. That's what we're going to look at. Right, so you can restart there. I'll make the animation speed slightly slower. Now, let's just go through with one number just to see again how that works. We've seen that already in the video at length, so write the dial tone, do all these things. That's just it getting into the dialer state. All right, so it will go inside the dialer part. I'm going to, in the meantime, try to keep this guy up because we want to see this happening. All right, I am going to dial one number through. What I'll do, though, I'll turn the animation speed right up so we can just go through that because we're not interested in it. All right, so you can see it full speed, kaboom, 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 down through. All reset. That's full speed. Now let's turn it back down because what I'm going to do is rather than send another digit through, I'm going to send a connect signal. It hits the connect, accept event action. It is on this merge. Recall it takes a while to do those evaluations. I will turn that up, see if it helps. When the animation speed is down, it makes Alf look slow. Alf is not slow if you turn up the animation speed to full, and it has failed. It prints can't dial yet. It has gone back through here and reactivated connect. Let's see that again. I'll turn this up and do it again and again. It is thinking, is the number valid? No, it is not valid. Can't dial yet. Back to connect. And now full speed. Connect. No. Faster than you can see. Slightly slower, just so I can see it. You see, you only have to have it a tiny little bit off the end, and the Alf looks slow, although it is not slow. All right, that's it. If I want to get through, turn it up high, and let's just finish off by running through some numbers. There's another number, and if I do a final number there, it will go through, do the connect signal, has done the connect signal, connect, number is valid, so connecting, went through the whole cycle we saw before. I've emphasized throughout that it's important that this operation, which is used for the operation of a call event on the trigger for this transition over here in the dialer, does not have an associated method. Let's look at what happens if it does. You can just get this one here from my little opaque library, which prints an int, assign the method, and we see now here in the call out, the print in is assigned. If I now run it, try to make it so we can see what's happening. I've got here small, the state machine. Let's run, and I will send a signal. Well, it's printed. It says int1 from my little library. It's gone into the start of this one, but it hasn't reacted here. Let's have another look. So another digit. So it went through there, but if we look at the state machine, it has not reacted. It's just printed the int. Okay, that is in fact described more or less if you look at the fine print in the UML 2.5.1 specification, and also it's indicated and explained in the Foundational UML subset specification. Now in the telephone dialer and controller, we used the action language for Foundational UML, Alf, in 2 spots, and this requires having the Alf plugin. Alf is good. Alf is UML friendly. Alf is elegant. But let's say you don't have the plugin and you'd like to do it without it. So we had this case here. Note we had to traverse a path through these part properties to get at the operation we want to use in our guard. And we had this one in our dialer. Okay, so to test it, I've made first a simple little test case, separate from the telephone dialer. What I have here is a class with a state machine as classifier behavior. It has a single operation that always returns true, just so we can test it on a guard. I have here signals corresponding to some of the different scripting languages that are available for use in opaque expressions in MagicDraw and Cameo. That's not all of them, that's most of them. I've got Alf because I have the Alf plugin active, but we're also going to see what we can do with the Action Language Helper API. Now, as a subtle point, note that that API can be used in combination with the other scripting languages. So it's of a slightly different nature than using these scripting languages directly, as we'll see. Okay, so we have also here a signal retry, and the sense of that becomes clear when you see the state machine. We're going to come in here to init, and what we can then do is go to a state that corresponds with testing each of those scripting languages to see whether we can get at the is true. Now with Alf, it's easy. You have a this, and we can just go this dot is true. That fetches the context. And it turns out you can do it, and you can do it directly on the transition on the guard using ALH. Right, so if I go to the guard of the transition, there is my Alf code, and it comes up here as under English. That's the name that MagicDraw and Cameo use for their default scripting languages. In any case, that is in fact accessing the ALH API. Okay, so let's just run it and see first what it does. Run with context. Clear all that. Okay, so it is now running. Let's do the Alf path first. Yes, it traverses that transition, and I can go back again. Let's test it with the action language helper. Now I'm using the self variable there. We could use the $context variable, or we could use ALH dot get context as explained here. In any case, if I go via ALH, it does succeed. I retry, I go back, and if I try any of the others, they will fail. So let's try bean shell, for example. I could not figure out how to access the operation using any of the other scripting languages. Maybe there's a way of doing it, but I could not find any way of doing it. So what happens is you get an error. Now, that might be okay if you just want to access an operation in a very direct context, but in this case, we want to navigate via a structural feature, a property. And in the other case that we had, we have two. So if you use the action language helper, that's going to start to get messy. Now you could put it as an opaque behavior and use it as the method of a separate operation. But that kind of defeats the purpose. So there's a side door for doing it, but we're asking ourselves, can I access an existing validation operation easily? Well, the basic answer is you can do it, but it's a little clumsy. So we'll change the model and see the best that I've managed to do using ALH. And there's our ALH version, not exactly elegant. If I look at the guard spec box, you see I have the language set to English, and there is the ALH. You have to get the dialer from the self context, then get the number, then get do this call on the operation, and it all involves using strings. There's no intrinsic awareness of the features. Anyway, prove that it works. Just quickly, animation set to full. I can, for example, try to do a direct connect, and it correctly says you can't, so it's failing correctly. I'll put some numbers in. It's two numbers just to make the point. I'll try to connect again. It says you can't dial yet. Put two more numbers in, and the last time it will correctly navigate our final test to execute the connect number 2323. Done. It works, but it's not elegant. Now, yes, you could put that whole lot onto a separate operation, but it's kind of cheating. Okay, Alf is more elegant.